Hey guys, welcome back to another code review video. The code I'm working on here was submitted to Discord for the final battle, and the person wasn't necessarily specifically looking for feedback. And actually, for the final battle, I like to let people just kind of explore and see where they're going. But they kind of looked at it and said, um, "Let me just make sure I got this right. Hang on." So their line is, "The code is spaghetti and it probably isn't as efficient as it could be, but I think it's okay for the first draft or attempt." And I 100% agree with that. I think this is a really good start. Um, and I think that the person's kind of thoughts of like, well, there's like spaghetti code here, there's things I don't like. I think that is a good indication that they're like on the right track. And like this whole thing is it's a learning journey, and it really does take a long time to get there. Uh, and so I definitely like anytime I do these code review videos, there are things in it that I want to point out as like, here's a different way you could do it. And I wouldn't be mentioning it if I thought it was a worse way. So obviously, like I think it's an improvement, or at least it could be looked at as an improvement. But I don't like this is none of this is ever meant to like reflect poorly on the people who have put in the hard work to get here. And I do think that like the fact that this person has put in this effort for the final battle is a big challenge. They've got 853 lines of code. Um, I it's this has been a monumental effort, right, to get to this point. So I definitely don't want to downplay um, the huge effort that's gone into this. And even if this person makes no additional changes, this is still a huge effort. I'm sure they've learned a ton by doing this. I think everybody learns a lot by doing the final battle challenge. And yeah, so like I said, I'm pointing out some things I think, well, what if we try it a different way? Food for thought, but it's not meant to say like, oh, it's all wrong or anything like that. Like I definitely, I'm always really excited to see people's final battle code because honestly, don't see that much of it. And like a lot of them, it's like a lot of the challenges in the book are some little fragment, like a little thing, and it's like there's only so many ways you can do that. Final battle, there's often so much variety in it, and I love seeing that. It's a lot of fun to see, and like I say, there's no wrong way to do any of this. Like there's the trade-offs with all these things. So again, I don't want to like uh, make it seem like, oh, it's all wrong or anything like that, even though I'm going to probably make some pretty aggressive changes. I just want to point out like the thought process that I use when I'm looking at code and thinking how we could do stuff. Um, so the first thing I want to point out is, so the way this works, like the way that the final battle is set up is it's supposed to be, I mean, you got the two parties, the good guys and the bad guys, the monsters and the heroes, or whatever you want to call it. This person has, you'll see this in the code. It's like the enemies or the friendlies. Like you'll see that enemy party, friendly party. Like you'll see that in here, right? Um, that's what that means. But so another thing in here, and you see that right here, is the program is supposed to be set up in such a way that there's a there's a player that's controlling the characters, and each of the two parties could be controlled by either a human or the computer. And the computer, like it, the logic that the computer is supposed to do doesn't have to be anything too fancy. It could just be pick an action at random, pick a character to attack at random, like whatever it is. It doesn't need anything too fancy. The human needs to get user input. So anyway, but the point here is that there is supposed to be this ability to choose who's going to control the players, and it's either going to be computer versus computer, which is actually usually a lot of fun to see like the game evolve really quickly because it doesn't have to think or like type in a bunch of commands. It just happens fast. Player versus computer, it's just kind of the default mode. Like I'm playing against the computer that's controlling the enemies, and then there's player versus player. So you get to control the uncoded one. Um, in theory, you could do it the other way around too, where it's a computer versus player, where the computer controls the heroes and you're trying to stop the heroes. Why not, right? I didn't, in the description, I didn't call that out as a gameplay mode. But anyway, what I want to do is I want to say, like, after choosing this, it comes in here to these methods. So depending on what you choose, it's either AI game, PvP, player versus player, player versus environment. In this case, they're counting environment as the computer, right? And I think that's fine. So what I will say though is like I looked at these methods and I thought, huh, it looks like what it's doing here is like this actually runs an AI, the computer versus computer game, right? This while loop, and it just kind of goes through all of the stuff. You can kind of see what it's doing here. True programmer has been defeated, evil wins, that kind of stuff. Like all of that's in here. Party 2 defeated, so all of this stuff here. And I thought that's fine. So it just kind of runs through a hard-coded list of, the battles. And then I thought, okay, well, how does that differ from the other one? So player, this is a human versus the computer. And I thought honestly, it looks pretty similar. So that one looks pretty similar at a glance. And then this player versus player also looks very similar. So I thought, well, how similar are they? Because one of the things about this is anytime you have duplicate code, and I don't just mean like, I'm trying to think of a good example. Like you have like, there's like duplication that's like the same thing for the same reason shows up in multiple places versus two things that happen to be coincidentally identical code. For example, to say, well, if you defeat this monster, you get 10 points. And we are going to have a padding, like 10 pixels in, we're going to inset. The fact that those are both 10 is coincidental. They are 10 for totally unrelated reasons. On the other hand, the logic that's in here is similar on purpose. It's because regardless of how you play it, the flow of the game is the same. So that's the thing is like if you have duplicate code that's duplicate for non-coincidental reasons, it's intentionally the same and you've copied and pasted it. What you do is set yourself up for if you need to make a change. Now you have to remember, oh yeah, there's 2 or 3 or 4, 10 places where I have to go change all these. It's easy to get it wrong. It's easy to like run into a bug and say, well, what's going on here? And you fix a bug in one place and not remember that you actually, this is copied code from, it's the same code as in 2 other places. And so you fix the bug in one place, but it's still there in several other places. Or to like remember that, go fix it in several places and then just forget one of them. And that is the type of problem that is worse the bigger the program is. Like if you are working on a program for a couple of hours, like a lot of the challenges in the book, like a lot of homework exercises, a lot of small programs, you will, it's just going to be you. It's just for a few hours and you can keep that all in your head. You'll remember it. But as the program gets bigger, I mean, imagine instead of something that you spend an hour or two on, something that you spend 1,000 or 2,000 hours on, an entire year's worth of work. You got 10,000, 100,000 lines of code. Maybe there's lots of people working on it. All of a sudden, these little things of like, I just copied and pasted the code, that's where you start to make those mistakes. So the more we can address those things from a software design standpoint, the better, the easier it is to maintain our code, which makes it, and that's kind of that's the big part of like software design and software architecture is how can we structure the code that makes this like evolution of the code as cheap as possible, like the least amount of time involved to maintain the code, to grow the code, to add new features and all that stuff. So what I want to do just to like illustrate, I'm going to come back up here. Because my first thought is, well, how similar are these, right? So I copy this, and then I'm using this tool called Beyond Compare. This is a really good tool that like compares different things. If you're using version control, it's just a diff tool. And a lot of version control tools will have a built-in diff tool. The ones that I have used, I have not liked any of them nearly as much as I like Beyond Compare. This is not a free program. You can get free diff tools and they're good enough. So like if you want to do this kind of thing, look up diff tool, DIFF, for differences. And like it's really useful when you're like making changes to code. You're like, well, wait, what changes did I make? You can compare where you're at now with the previous commit. So that's what this is primarily used for, but it's also useful for just random compare the two things. So I'm going to grab this player versus environment and drop it in here, and then I'm going to bring this back. This doesn't have the ability to like zoom in, or maybe it does, but it's not. I don't see it. I don't care. Anyway, the text is going to be a little smaller than I like to do for a video. But what you'll see is the way this is done. This is it's all these little red marks are the differences, and so like you can see the lines up here, like with which lines are different, and you can see like within the text like how it's different. So obviously the methods are called something different. That's not surprising. And then the only other difference here is this is party.friendly attack. And this is also friendly attack, but it's player friendly attack. And down here, it's the same thing. So this is, so this is basically this while loop deals with the first battle. This while loop deals with the second battle. And this while loop deals with the third battle. And in all three cases, it's the difference here is we use this player friendly attack versus the not player. It's the one that is the computer doing it. So, and I'll also point this out. These are static methods, right? Party dot player friendly attack and friendly attack. So there is, and I guess I could bring in, like, let me compare this player versus player and drop it into either of these. Again, the only difference is whether we call player enemy attack 3 versus enemy attack 3. And yeah. So like these are all, like the only difference is which of these methods we call. So the goal is to, this is, I don't know how many lines of code this is. It said 92. This one over here says 93, so there's a blank line there. But so it's about 100 lines of just about duplicate code. The catch is I can't just like make a, like that's the simplest thing we could do to remove the duplications, to just make it one method. Or to take the common stuff and just make it one method. The problem here is we've got these little fragments that are embedded in the bigger pile of stuff that we could, that make it hard to just be like, okay, here's a chunk and it's just a method. We'll just call that one method from both places. So what I'm going to do, I don't need this anymore, so I'm just going to discard it. But what I'm going to do is I'm going to go to those methods. So player friendly attack. And let's look at what we can do here about this. So like you can see this method, just so player friendly attack, it goes in here and just iterates through all the characters that are in the friendly party and has them do this player action, right? And the non-player version does this AI action. So that's those two, and then the enemy attack and the player enemy attack. Like it basically, ultimately the difference comes down to this AI action method for a character or this player action. I guess I feel like there's a lot that we could do here. Because like, so this is like, there's the different implementations of this, right? So like the true programmer skeleton uncoded one. And all of these have probably similar code. So what I want to do is I don't want to get too far down into that path. So let's back up here. What can we do? Okay. Well, the first thing we can do is, like I said, the only real difference here is which of these methods we call. So let me back up all the way. It's this right here. Which method do we call? What I'm going to do to sort of wedge in some flexibility, because that's what I want to do here is like, yes, I want the I want to choose either the player friendly attack method or I want to choose the other one. What I'm going to do here is I'm going to what I'm going to do here is I'm going to come up to I want to make a new type definition. So this is where our types begin. And I'm going to come in here and public class. I'm going to make this abstract. Public abstract class player. Or should I make this an interface? I'm going to make it an interface. Public player. I guess we better call it iPlayer. And then we're going to say public void. What were those? Make sure I'm calling the right thing. So one thing I could do here, like I said, there's actually, well, now I've closed it. Why did I close it? Let me do this again. Come back beyond compare. So there's the differences here are whether we do the friendly attack versus the player friendly attack, and same with this and all these down here. Oh, and I guess the one we're missing is this one has like enemy attack 3, friendly attack, enemy attack 2. So depending on which round it is, there's a separate method for enemy attack for round 1, enemy attack for round 2, enemy attack for round 3. And I think we can clean that up too, because I think those are all about the same thing. But let's start with this. I'm going to, like I said, I like to do everything in as small steps as I possibly can. Sometimes those small steps end up being big, but the smaller we can make steps, the easier it is to say, I got to stop doing this like cleanup or refactoring and do something different. So little steps is definitely a good thing. So what I'm going to do is I'm going to make public void friendly attack. I don't need the public on these interfaces. That's a given. Void enemy attack. I'm gonna, like, the other code didn't have 1 in it. I'm still gonna add that in. I'm gonna add that in anyway, just because I think that's the symmetries. It is for round 1, etc. And then here's what I'll do. I'm gonna, like I said, keep this really simple. So public class human player is an I player. And then we just got to implement this interface. Yes, all of them. And then what I'm going to do, and this is where this gets interesting, I'm going to leave the other methods intact. What I'll do is I'll just do, it was called party dot friendly. It was called friendly attack, but in this case, it's player friendly attack, right? Oops, that one's not friendly. That one's. All right, so something like that. And then I'm going to do the same thing for the AI player with just the non-player party methods, right? So let me skip ahead for that really quick. So I've got this AI, having to call it AI player. And so this just calls the non-player prefixed version. So it just calls friendly attack, enemy attack, all the way down. And now what I can do is so now if I have an instance, so I basically put like an object-oriented, like instance-based kind of thin layer over the top of these static methods. The static methods still exist, but we wedged in this now I have this polymorphic behavior. Like I don't know necessarily which type of player I'm going to have. Whichever one it is, I'll have, I'll just say, hey, player, whether you're a human player or an AI player, I don't care. But if it's the human player, we'll call the player versions, and if it's the AI player, we'll call the non-player versions. So all those methods exist as static methods on this party class, but we now have like this I don't even know what to call it, this like layer in between that can like redirect all those requests to the player versions versus the AI versions, right? So it's a simple change to just kind of wedge in some object orientedness atop static methods. And I've said this a bunch in Discord. I've said it in these videos. Static is very useful, but it is not object oriented. And so like you leave stuff on the table. Like if you're saying player friendly attack, when you call that line, you're kind of locked into this is what it's going to be. There's no way for this code to do anything but call that thing. So you give up your ability to use like polymorphism to substitute one thing for another, things like that. And so it has its uses, especially for things where you don't want that flexibility. You don't need that flexibility. In this case, though, I think it's useful to get that flexibility because it's going to allow us to collapse those three methods, the player versus the PvE, PvP, and I don't remember what the other was called, AI, I guess, to like collapse that down. So what I'll do now is I'll come in here and I'll say, at the start of this method, I'm going to say I player1 equals, hang on, I got a cat that's decided he's going to come sit down on the keyboard. Too bad I don't have video or you'd be able to see this kitty cat. Anyway, he's laying down here next to the keyboard and he'll probably eventually decide he's going to flop on it anyway. Or maybe he'll just fall asleep. We'll see. Anyway, you can't see the cat, so I should stop talking about the cat. What I'll do here is I'll say, so this is the AI game, so this will just be new AI player. Typo. That got really slow for a second. And then I'll do player 2. And now, instead of this kitty, okay. Yeah, so now instead of calling party.friendlyAttack directly, what I'm going to do is say this is player 1's turn. So I'm going to say player1.friendlyAttack, which we know because we don't know which player we've got like by this type, but we do know in this specific case that we're going to be using AI players. And so we know that this will call the same thing that it was calling just a second ago, like indirectly. It goes through this extra layer, this player, and we just have to like finish that out. So I'm going to go through the whole method and do that, and then so basically we'll skip ahead, and then I'll come back to that. So, but I will say that like this one should be player 2. Like this is player 1, this is player 2. All right, so I've just gone through all those, player 1, player 2. And then now I'm going to come down here and like what I'm going to do is same thing as I did up here. I'm going to create my 2 players. But this time, because it's player versus, it's PvE, it's player versus environment. Instead of this, I'm going to do new human player. And then I'm going to basically make the same change. So player 1, and this is player 2. And I'll just do that through the rest of these. And then for the last one, I'll do the same thing, but this is PvP. So both of these should end up being human player. But otherwise, this is the same. All right, so I've completed that now here. Like I said, in all of these cases, the only difference is which player, like, so before we just called the party classes static methods, and now we're calling these other ones, which happens to route the right direction, that the human side or the AI side, right? Like it goes either way. And now that determination is made by, well, which instance? Did I make a human player instance or did I make an AI player instance? Now let's compare these again and beyond. So now you'll notice that I have a lot less, like there's fewer red lines. I do have this here where I have a blank line in one place, and it's showing up blue because it's just a white space difference. I'm just going to delete that. I don't care about that. So the only difference now is just the name of the method and then whether we're using a human player or an AI player. So basically the only difference now is just which of these are we using. Um, that is a really good place to be because now the bulk of the code is identical. Um, so I think that's the next thing for us to solve here. All right. So what I'll do is I will I'm going to make another method called void run game, and I'm going to hand in I'm going to pass in the two player objects that I'm using, right? And then I'm going to take the entire rest of this code. I'm going to just move it in here. And so now all the code is still exactly as it was, other than just now it's moved over into this run game method. And then here I'll just call run game player one, player two. And then this down here, like I said, given that all this is identical, we did have that one white space difference, but given that all this is identical, now we can just run game, again, player one, player two, except for that in this case, it'll be a human versus an AI player. And the same thing here. I can just delete this and just do run game, player one, player two. And what was once 853 lines of code is now 707. That's about 83% of the code that we used to have. So we've cut out about 17% of the code by making that one change. And I will say that like the bulk of the code is still what it was, right? Like it's a very small change that we've made to do that. I actually want to go just a little bit farther here and say, I don't necessarily need these stored as local variables. I could just, like I'm totally fine with just sticking these in here like that. And same thing with this. Like I don't need to put them in a temporary variable just to pass them down to this run game method. You can if you want. There's like this is definitely a personal preference. I will like my tolerance for like putting a larger chunk of logic on a single line is my tolerance for it's a bit higher than many. Um, yeah. So if you prefer it the other way, you do it the other way. That's fine too. But anyway, and then like the last thing is like I kind of feel like at this point I'm not even sure these methods do much. Like do I really need a specific method to just call run game with different parameters? I don't know. Like I could. The alternative here is I could just kind of remove the method and just drop that in there directly. It's only used in one place. And then I almost deleted the run game method. That would have been silly, right? However, I'm going to do that. I want my white space to make this clear what's going on there. So now aligned more vertically. And so at this point, it's pretty easy to say, well, like if I did want to flip it around and do computer versus player, like I just had case 4 and I just say run game, new AI player, common new human player. And now I have that fourth scenario as well. I'm going to just, I'm going to just delete this. I was going to say that Visual Studio, that might not be Visual Studio. That might be Writer, which is a plugin for Visual Studio. Like inserting it to say, well, at this point, it's all done. We don't need anything else. Okay. I think I want to go another step farther, and that is like at this point, Let's go make sure of this. So this is used in one place. This player friendly attack is used in one place. Enemy attack is used in one place. Player enemy attack is used in one place. Enemy attack 2 is used in one place. Player enemy attack 2 is used in one place. Enemy attack 3 is used in one place. Player enemy attack 3 is used in one place. Right. So all of these methods are used in one place, and that is the places that we just barely told it to use it. So, I mean, what I'll say is at this point, like we've made a change, and like from a maintenance standpoint, like if we now there's only one place where like the whole like running the game is defined. So this is the code that we've condensed, and it makes a big difference. Like I said, it's about 150, just short of 150 lines of code that we cleaned up. Actually, now we might be, yeah, we've removed more than 150 lines of code with that change. So with that change, like we've made a lot of good progress, but I think we can do more. And one of those is like, rather than having this like hand off to the static method. Okay, wait, let me take a step back. We've made a single meaningful change. If I were using version control, I'd be committing right now. Not everybody likes to commit that often, but for me, I'm at a nice, stable point. It's time to commit. And in fact, if I said, you know what, I don't have more time to keep working on this, I could live with that. We've made the code better. And that is a worthwhile change. And it took us, well, I don't know, it might have been 10 or 15 minutes. But, and had I not been explaining everything, it would have been faster. But what I want to do now is let's make another similar small change. And all I'm going to do is this just calls one of these static methods. I'm just going to move these 8 static methods into either the human player one for this one, this one, this one, and this one, or I'm going to move the AI version into the AI one, right? So that's what I'm just going to sort of scoot everything back into their classes and remove all these static methods. And I'm not going to show you all those changes. I'll just skip ahead to that. All right, mission accomplished. The only thing now is that these methods in the place they were at had access to this friendly party and enemy party 2. These are in the party class, and it's these static things here. Now on the bright side, these are public and static, and so from where we're at, all we have to do here is just do party dot enemy 3 and just do that for all of these. All right, that's another step done. So now all of these, just the code that used to be in that, the static methods that used to be in the party class are now part of either human player or AI player. And again, like in theory, we could add a different kind. Like we could add a network player, or I don't know. We could have two different AI players and write different code in both of them and have them fight each other to see which one's better. Or there's a bunch of things like that we could do. So we open up room to have different types of players. So yeah, we've made good progress, and I like where we're at. And again, this is another place I'd say, well, I can commit that. We're in a good. We could stop here if we needed to. I do want to keep going though. So this is a good time for a break, and maybe I should stop and record a second video to break it up a little bit, but I think I'm gonna not. I think like it's really easy to look at this and say enemy attack 1, 2, 3. The first thing about this is like when I go to these, so enemy attack 1, 2, and 3, these again, if I put them in beyond compare, I'm not going to do that here because I think it's easy enough to see. The only difference between these is whether we use party.enemy party, party.enemy party 2, or party.enemy party 3. The rest of this is identical. Interestingly, the same thing is true for friendly attack, just well, there's a couple of differences. There's the we're using a friendly party instead, but then the other thing here is, oh, never mind. Those are the same. So all of these are the same. It's just a question of which, and these are all lists of I characters. So it's just a question of which list do we actually do, right? Closely related to that is the fact that this run game has, like, it runs the first battle. Oh, wait. Oh yeah, so that's the first one. Here's the second one. Actually, that includes this as well. And then here's the third one. So, and those are, there's a lot of overlap between those. And so the question is, can we do something about it? Can we make that simpler? All right. So like I said, there's duplication here. There's duplication up in that run game method. I'm going to deal with the duplication here first, because I think what we can get away with here, like I said, all of these are the same except the specific list that we use, and we can pass that list around. So if I come in here and I make a private method, private void attack, and then I have an I. Wait, what was that? It's a hang on. It's a list of I character. So attack I. Sorry, list of I character. Party. I'm going to call it party. So if I do that and I take this code, I'm actually going to just put it down here and then replace this party, and then this right here can just become attack party.enemy party3, right? And so now this will just call down into this method using it's a parameter, so it can be something different, which gives us the benefit of, well, now this enemy attack 2 can just be enemy party 2, and we can keep going. This can be enemy party, and that was just enemy party, and this one can be friendly party, right? Yeah. So like I like the direction this is going. We just got rid of even more duplicate code. So if we say do the friendly attack, we use attack and pass in as a parameter the friendly party. If we say do an attack for the enemy party 1, we pass in enemy party, which doesn't have a number, but that's fine. 2, we do 2. We just pass it in, nice and simple. The other thing, for example, like now that we've removed all that duplicate code, this is saying, well, you don't enumerable.count. You could just use the plain old count property. So enumerable.count actually requires walking down the whole list. Like it has to like literally go down and count. And if you got 1 or 2 or 3 items in here, which we like in this case we do, it is a tiny amount. There's not a lot of cost to it. But if there was a million things in here, walking down the whole list and counting them all as you go is not as efficient as this. And not to mention, I think it's less code. I think that makes it easier to understand. So I think that's a win-win. And that's why, like you saw that I don't know, again, I don't know if that's Visual Studio or Writer that often has stuff like that. It was suggesting replace enumerable.count invocation with collection count property access. That right there is what it's suggesting. Actually, I think if I'm not mistaken, I think this little thing will be like, I think I just click on this and it'll just be like, yep, I'll do it. So if you don't know what it's saying, you can always click on that and see if you're comfortable with it. Now, what's interesting is the AI player has the exact same thing going on. And we can do the same thing down here. So I'm just going to cut this to private void attack with a list of I character and rid of that count. And then in here we can just call attack party.enemy party. And same with all these other ones. So we're actually down to 656 lines of code. We're down about 200 lines of code total. Another thing I'll say at this point is maybe we don't need all these methods, right? Like maybe we just pass in the party that it's supposed to run for. Like, well, what would that look like? I already have an idea in my mind of what that's going to look like, but that's again like a lot of these look fairly similar. Are they? Is that providing a lot of value? Maybe not. Oh, you know what else I want to do here? I saw this like this could be a for each loop. And for me, the for each loop tends to be easier to read if all you're doing is iterating down it. So I'm going to do that, make it for each. And same with this one down here. Anyway, yeah, all these methods that are just kind of, they all just funnel you to the attack method with the right thing. I like, what if we just made this a public method and just said, look, I'm just going to do this attack and you're just going to tell me which party to run. And it's like, what if we just make this public and then delete all of these, basically make that be the interface. And this is a bigger change, but I don't think it's anything too crazy. And if you wanted to break this up into multiple steps, then the way to do that would be like you could make this top level like this, like does it parameterize any party? You make that a method in iPlayer, and then you start making everything use that instead. Oh heck, I'm just gonna do it that way. Why not do it the baby step way? All right, so for example, we start by saying, okay, we'll make this, it already is there, public, make that public, make this public, like it spell. And then we come up here and do void attack with an, I don't know why I keep wanting to do iList. A list of I character. I mean, iList exists. There's a reason for it. And I often use it. So it's some sort of like muscle memory or brain memory. Oh, wait. Brain memories are just called memories. Anyway, so we make this exist. And then we come up here and in these places where you say player 2.enemy attack 3, we would just say dot attack party dot enemy party 3, like that. And now what I would say is, I think what we'll see is, yeah, this is now saying, look, it's defined as used, but like nobody's using that anymore. Okay. So let's keep going down that path. So we call this player2.attack party.enemy party 3. And then right here, we can do the same thing. We can say player 1 dot, we replace this with attack with party dot friendly party. And we just do that for all of these, which I'll skip ahead. You don't need to watch. So once I've made all those changes, now these, like it's saying that these aren't used anywhere. They're defined, they're declared in the human and the AI implementations, but nobody's calling this, which now I know I can just delete that. And now this is going to say none of this stuff's used either. It's going to gray those out. I don't know, but it says 0 references. So now I should be able to delete all of these. And I should be able to delete all of these. And now our two player types are nice and simple, which I like that. So again, another milestone, another place where it's like we could stop ourselves here if we wanted. By the way, now we're down to 613 lines of code. We started at 853, so we're down about 250 lines of code. I'm kind of focused on that lines of code, but I want to say that lines of code is not a good measurement of like value. um, there is plenty of like adding more code doesn't make it better. Removing a bunch of lines of code, like the main thing that we're doing here is it's not about the lines of code. It's that the code is easier to maintain. That's the real value we're getting here. It happens in this case. It happens to be showing up very clearly in the terms of the total number of lines of code, and that is so. That's why I keep looking at that. I think that that makes it interesting. Um, but like I said, you don't want to overemphasize lines of code for good or bad because it's just not that good of a metric of much. Here's I'm still looking at how to like remove this duplication, and this is what like I keep pausing it so the video doesn't end up being hours long. But one downside to that is you're missing the fact that I'm stopping and like thinking about what am I going to do next, and you're missing that thinking. So don't think that this just is like obviously like if you're an expert, you obviously you'll just know the next obvious step all the time. You are missing the thinking and the kind of analysis that I'm doing, and it can be like some of these little gaps that you're missing are a few minutes long. So like it's taking me time to think through what I want to do next, um, and I think that's maybe a bad thing. Like the fact that you're missing that, but I also don't want you to sit through that. That's kind of boring too. What I wanted to say though is here's a while loop. This is for running the first battle. So in this incarnation, there's three like rounds. So like the heroes fight three different waves of enemies, and you can see that here. So like this is added to the enemy party, the first one. So you fight one skeleton, then you fight two skeletons, and then you finally fight the uncoded one. So this right here is the first battle, and this loops until the battle's over. And then here, it's the same thing. We loop until that battle's over, and there's just like a little bit of extra, depending on stuff, like all enemy parties defeated. You proceed on to face the encoded one, and then here's the third battle that like loops until we're done with the third battle, and then this is the thing I want to say. Then we hit this break, and this break escapes this while true loop, but in all cases, like we will the loop is while true, but we will always escape that loop and then leave this. I think that we can make this a little easier on ourselves mentally. And like I said, I suspect this is very normal to have code that just kind of evolves. It's like a garden, and it's like the weeds in the garden sometimes is you're like, well, I'm not going to pull this out now, and then eventually you're like, huh, there's a lot of weeds in there. And it can be sometimes hard to like, I mean, we just a couple of months ago we had this thing in our garden where we planted a bunch of beans, but we planted it in soil that like had a lot of grass seed in it for some reason. And when the beans started growing, we were looking at it saying it's like there's beans and grass growing, and if I pull out the grass, the roots of the grass are messing with the like I'm gonna accidentally kill a bunch of my beans. So do I just wait? So we actually didn't pull out the weeds, and then now it's the beans are really intermixed with grass still. So like some of that's what happens here is it's like you didn't mean for it to be this way. It's just kind of how it evolved. And so like what the kind of stuff we're doing right now is going through carefully and saying, okay, this is beans, this is the grass, which grass is fine, but not among the beans when you're trying to grow beans. So it's like we want to get rid of the grass and keep the beans intact. And it can be a little tricky to like see some of this sometimes. But in this case, this while loop will always run exactly once, because once we get through all of this, then we break out of the loop. And that's it. There's no like repeating it. Now, there is an argument that maybe we want to be able to run the game indefinitely. Like even once it's over, let's just start fresh and run the game again. But in this case, like, so maybe we want to keep this intact for what we want to do in the future. Like if we want some grass in our beans, then we wouldn't pull it all out. But in this case, having not written the original code, I don't see the compelling reason for it. So I'm just going to delete the break, delete the loop, unindent all this, and now we have simpler code. Did we just remove a potential feature for the future? maybe. Um, all right. So the next thing I want to do in terms of cleaning this up is like this. That was a little weird. Okay, it didn't do it there. This code here. So from here down to, well, let's say here. That is the first battle. From that line down to, I'm going to say this one is the second battle. And then this down here is the third battle. And I want to put this in beyond compare and just see how different they are because they look a lot the same. So let's just take this while loop down to that line, paste it into beyond compare, and then do the same thing with the second one. And then compare the two. And so one difference is that this one, this is the first battle, checks to say, do we have at least one friendly character still alive? I'm assuming the count, like if a character dies, I'm assuming they get removed from the list. I guess I haven't confirmed that in the code. So that is a thing that is different between these. Another thing that's different is this one uses enemy party, the first one. This one uses enemy party 2. And it uses it here, and it, that difference here. And then this also has like, there's this text here of like what to say when you win. And then this one and then of course this attack uses enemy, like it's just the second round. So we use enemy party 2. This one has this thread.sleep, and it also has this text like, once you've won, all parties defeated, you proceed on to face the uncoded one. So the differences here are not huge, but they definitely exist. And what I mean, let me bring up the third one here as well. Is like, so the third one, again, it's also using this, and it just has a different message here for like when you win. And so one thing I'll say is I actually think, like, I think that like in like this one has like all this extra text, and there's a part of me that wants to say, why do these different? Like, why have, like, the first one didn't have this thread.sleep, the second one does, the third one doesn't. The third one doesn't have this console.write line, but the first and second one did. Each of these have like this different text in here of like what to do. And one thing we could do is we could just say, I'm not going to make any differences between these. I'm just going to delete the differences. But I hesitate to do that. This is the functionality this person wanted. There might be a good reason to keep it that way. So what I want to do is just work my way toward similarities, and when there's a legitimate difference between them, I'm going to try to just account for it. It would definitely simplify things to not do that. But the first thing I want to do here is I want to say this run game, the biggest difference I see is the fact that this one has this extra if statement. But and again, maybe I'm just missing it. I don't think this is any. Like, I think I can just take this text and put it right in here. So we say party 2 is defeated, and like the flow of execution, if the count is 0, then we're going to change it green, say party 2 is defeated, make it white, break, which leaves this loop, and then comes down here and says, is it 0? Well, in here it was, and then we change it back to green, say all enemy parties defeated, you proceed on to face the encoded one, change it back to white. And so I think if we just take this text here and stick it here, then I don't need this. And so that's one difference resolved, is the text between it is different. And And then like another difference was this one is checking to like make sure that like there's friendly parties alive, right? Like, but again, like I actually, that's probably why this doesn't matter. I think my guess is this line got put in here early, but in this case, like right here, this is the check that says like so the players take their turn. If we've eliminated all the players, we're done. Then did I say, what did I say? If the friendly players, if the heroes take their turn and have eliminated all the enemies, we're done. Then the monsters take their turn, and if there's no heroes left, we're done. So in that case, I actually think like this will be met by getting into this and hitting this break and leaving the loop, and this will be met by getting in here and hitting this break. So I actually think I could get away with just saying while true and doing the same thing here and doing the same thing here. And then, like I said, this has this write line and this sleep, and I kind of feel like I said, the first one up here has console.writeLine, and this one has console.writeLine and thread.sleep, and this one has none of them. I guess in this case, I'm going to say why be different? Like why not do the same thing in all cases? So I'm just going to like, I don't feel like that changes behavior. I think it actually just adds consistency. I think that's a good thing. And so why not be consistent? There might be a reason for it. I just don't know what it is. And with that, I think I'm going to do beyond compare again now. And we're going to see what our differences are now with all of that in there. So copied, everything's over. And then like beyond compare, and I don't like, for some reason, the F7 buttons, like you always push F7 and it says it in there too. Like if I say align with, it doesn't have that for some reason I can't explain. But if I do it right, I can like, it'll like allow me to, as you can see, it's like align with, and I can just pick this guy and this guy, and it like makes sure they're aligned. For some reason, it's like not working right. And then somehow my white space, I don't know what's going on there. Well, true. Do I just... Huh, interesting. So I've got four spaces here and only 3 on these. And that is probably something I did weird. Because before when I compared them, it didn't have that problem. Let me try this again. Huh. It's got 4 spaces in there. What are you doing, computer? Okay, there. This one has an extra line that I copied. So now at this point, the only differences are whether we use the enemy party 2 versus 1 over here and the text that we display between rounds. So I feel like we're actually really close to like consolidating these. And I think that we can do that. So what I want to do, and the third one is the same too now at this point. It's just different text here and then a different enemy party here. So what I'm going to do, just to keep this simple, is I'm going to come up here and I'm going to say string victory message equals, actually, what I'll do is I'll declare that variable, and then I'm doing it this way on purpose because I know where I'm going with it, I guess. But victory message equals, I just want the string, not the whole. And then down here, I'll say victory message equals, I need all three of these lines. And there's a few ways that I could do this. Like one thing I can do is I say party 2 defeated, and then /n, new line. All enemy, where's my space key? All enemy parties defeated /n. You proceed on to face the uncoded one. Like that works. Alternatively, I think this is a C#11 feature. It's not covered in the book, but it is covered in whichever expansion, the C#11 expansion or the C#12 expansion, which are free PDF only downloads. I can do this triple quote, and then I can do party 2 defeated, all enemy parties defeated. You proceed on to face the uncoded. So I can do it that way instead. I said I did console.writeLine, but I actually, I guess I lost track of where I was at. All right. Anyway, if I do it that way, like I can do multi-line thing, and it, like all this white space here doesn't get included in the string. And yeah, so like it's smart enough to say, okay, any leading white space here, expect to find that on all these other lines, and then you can just split it across multiple lines. So I love this feature of C#. I think it's 11. It might be 12, but I'm pretty sure it's 11. And so I'm just going to use this. Up. I'm in the wrong spot. So this stuff, I want that right there. Semicolon. And then this can be that. And then down here, equals little excitement. Like that. And then, so at this point, like we're super close. Like the only difference now is going to be this plus, like in here, it's like party.enemy party 3. So we'll do the same trick we used before and say, okay, I'm going to come up here and I'm going to say, so I'm going to make a list of I character current enemies. And then right here, I'll say current enemies equals party dot enemy party. And then I'll just basically swap that out. So now I'm going to use this. And is there other places where we're using that? I feel like there were. Maybe not. Maybe that's it. Enemy. Oh, right there. Right there. Right? Yeah. And then down here, I'll say current enemies equals party.enemy party2 and do just replace this as well. All right, that was a lot. But now at this point, and again, like I said, I actually feel pretty good about saying we've made progress. And if I had to commit this and ship it and move on, like I could live with what we've got. But one thing I will say now is I think if we do beyond compare now, I think we're going to see that the only difference is what values we set here, which will be a good spot. So let's confirm that. So for whatever reason, I'm still getting some of that white space difference. Like this one's all indented and this one wasn't. I don't understand that. I could do. Oh, I need to go the other way. It's still doing it. I don't know. Oh, indented too much. Oh, but this is putting in a tab. That might be part. I think this is just some of it's just it not recognizing. All right. Yeah. So other than those little white space things, that is partly my fault and might just be tabs versus spaces. The only difference we see is just how we initialize this at the beginning, and that's a really good thing because now, and I'm not gonna check it down here. I'm gonna just assume. But now what we can do is we could make this like a method or something, and we could say we could do something like just take all of this and do extract a method, run. What are you doing? Take all of this and make a method called run single battle. And then we'll pass in player 1, player 2, victory message, and current enemies. To generate that. I love where it stuck it. So this is a local function of the main method, and this is a local function of run game. This is not where I want this. Player 3. Really? Player 1, player 2, victory message. Current enemies. So I've actually intentionally told them to use the same names as this, which is now hiding all of the things that it technically had access to. But in a second, I'm going to just move this entirely out of there. I do not want that as a nested method of a local function of a local function nested times 2. So there is the first battle, and now the second one I can just replace all of this and that with run single battle, victory message, current enemies. I need more, player 1 and player 2. And then down here, same thing. And yeah, so like now all of that stuff has been simplified. All that duplicate code is the same. Like, and there's even this, like there's a part of me that wants to say, like, I kind of want to just inline all of this. That's really easy to do with the current enemies. So I'm at least going to do that with this. These strings to like inline. Like I don't feel bad about this one, but these multi-line ones I don't love. So now I don't need the current enemies at all anymore. It's just the victory message. And I guess the only reason I haven't consolidated that is because of this. Now, I'm gonna I can keep going. I could do this all day. Like I really could. Where are we at? How many lines of code do we have? 579. So we've almost removed 300 lines of code. If we made, so right now, like if you look at that party class, it has this list of like list of character, list of character, list of character. Um, if like so this is a like it this is a class that isn't about a single party. It is about kind of management of all the parties. And I actually wouldn't mind having a class to handle a single party, which is really like in a lot of ways it's just one of these lists. But as you'll see in a moment, I think that like yeah. So what I'm going to do is I'm going to rename this to the plural parties. So this is like a static class to support all the parties. Um, don't rename anything else. No, don't do that. So now all these things will be like parties dot whatever instead of party singular. Yeah, parties dot friendly party. So now it's like here's like a list of all these known parties. And then what I'm going to do is I'm going to make a public non-static class that's a singular party. And then I'm going to make public list of I characters. And then what I'm going to do is I'm going to, so this is a wrap, right now this is just a wrapper around a list. But what I'm going to do is I'm going to come into all of these and I'm going to replace the list with a party. And so now all these things, this friendly party used to refer to a specific list. That's, you see all this red. So I'm going to pause the recording and just fix all this. But basically all I'm going to do is friendly party dot characters dot add for all of this. And there's a lot of them, but it's not hard. It just takes a moment, right? So hang on. All right, that took a little bit, and maybe we'll look at the reason why. There's a lot of references to these different parties down in here. But the reason I'm doing this is that at this point, there's a lot of room for me to. So, for example, if I say run single battle, and if I don't pass in a list of characters, but I pass in a party, um, I now have room to I now have an object that allows me to stick the victory message. So like if I go to here and I say public string victory message, I'm just going to make that settable. Now I what I can do is I can say I can take these victory messages here and just like put them in this. So let's see. So this will, I'm trying to think what the best way to do this is. All of my parties are created right here. So if for example, I could do victory message equals, what did I do? It's like I can take, so victory, I'm just going to scoot all these together so that I can just move them all down and do. So I can just set that property here using object initializer syntax. Oh, I did that wrong. This one doesn't actually need a message. This one goes here. And this one, number 2, goes there. And the third one goes there. Clean this up. I actually don't like that formatting. I like that a little better. All right, so these are like now basically each party now has their own victory message set up right here. And like, for example, one thing we could do, it's pretty easy to imagine these not being part of this like parties list. Rather, it's easy to imagine maybe these are defined in a file somewhere. We just load all this from a file or something like that. And with that now, I actually don't need to pass in the victory message at all because that's a part of the party. And we're actually passing that in. So now I can just come down in here and just do remove this victory message and just do current enemies dot victory message. Now, what's interesting is like I actually could make it like if you defeat the heroes, the friendly party, like I could make this be the victory message for that, but this also has a different color. So like we'd need want to like I don't know, you maybe want to account for the color in the same way, and I'm not going to get into that. But now what I like about this method, I don't need these anymore. What I like about this now is this is just a loop, right? So now I can just say party array enemy parties equals new party. Actually, well, okay. New party parties dot enemy party parties dot enemy party 2 parties dot enemy party 3, and then I can just say for each enemy for each party, enemies in enemy parties, run single battle, player one, passing the 2 players. Just like that. And what's nice about this is now if I want to add in a 4th party, I can just add it in right here. Like I could just say new party and just add in another one really easily. Like I don't have to have like this fixed list. In fact, at this point now, I'll bet we've got fewer and fewer usages of these. This is going to suggest a C# 12 feature, which I like. Or is that a C# 13 feature? I'm using the preview version. You can see that here. So it might be just a C# 13 feature. That syntax. I love that syntax. It's really good. That might be a C# 12 feature though. So I'm going to leave that not that way though. I've put in a lot of time onto this. Like I said, we've made a lot of progress. So we're down to 579 lines of code. We almost lost 300 lines of code out of 850. The biggest thing that I see here that's still a lot of duplication is it's all this stuff. So there's this AI action, there's this player action, and this versus this, and then like there's that inside of the skeleton and inside of the true programmer. And inside of the uncoded one. So the way this is going, it's like every monster type that you create needs to like duplicate all this. And it'd be nice to not do that. I definitely need to stop for tonight. This is already a very long video. There's a part of me that wants to keep going, but I don't know that I should. So what I'm going to do is just suspend recording, and I don't know if I'm going to get back to this tomorrow. So if not, this might be the end of it. And if so, I'll just see you next time. We've made good progress here. Otherwise, I might do a little more cleanup tomorrow. Like I said, I think like all of these constructors they're all like it's the same thing as before. Like we can look in beyond compare or some other thing like that, or we can just like analyze it ourselves and see how different the two are. But like this is a really good candidate for what if we do this a little differently. But then like a lot of this stuff here looks at a glance looks very similar. And like I guess I feel like we could probably, using some of the techniques we already used, we could probably make that simpler. So yeah, I don't know if I don't know if I'll get to that tomorrow. So this may be the end of it, and if so, then we've made some really good progress anyway. But I might be back, so you'll be able to tell because you'll be able to look and see if there's still 4 more hours of video. Hopefully not, or if it's just the end of it. So I'll maybe see you tomorrow, or maybe this is the end. Either way, I'll see you next time. All right, we're back. Let's look at, there's these 3 different like character types, right? All 3 of these are derived from, they implement the iCharacter interface, and all of them are structured fairly similarly to each other. So it starts with this nested, enumeration of like the actions that character can do. Nothing and punch, and if I look at, for example, skeleton, nothing and bone crunch, and then the uncoded one has nothing and unraveling. And then there's these things. These are necessary to implement the iCharacter interface. It needs a name, max HP, HP, and then it has this that's kind of interesting that it has this enumeration of actions in here. You'll actually see like it has 0 references. So even though everything else has this, like the way that's set up doesn't, I guess I'd say that's probably not working as expected. Like I can just delete this and it will be fine. Because you can't in a interface state that, oh, it has to define um, a nested type like that. Like that's not a thing that you can convey with an interface. And so like this is not, like you can also see this here, like this has this little icon here that it implements that. This doesn't implement anything. So I actually like, what I'm going to do is I'm going to just delete that. It doesn't need it. I'm actually, now that I'm in here, max HP doesn't change. That doesn't mean that you couldn't contrive of a reason for the max HP to change over the lifetime of a character, right? Like it's possible, like in a game, like this game won't require it, but it's possible that in a game that the max HP could change. So I'm going to delete that, but you could make an argument that you don't, that maybe you want it to be settable. The name also isn't being set anywhere, so I'm going to clean that up too. And yeah. I think I could be wrong about this. I think that I don't need that to be settable or this to be settable now. So far, so good. Um, and then uncoded one. So again, these are just like, I'm not going to make the interface more complicated than is needed for what I'm doing. There is an element of like, think about like, what are you going to need in the future? Because thinking about what you might need is not, it's not unreasonable. You just, there's a balance there. You don't want to go crazy like thinking about what could be and add in a support for a bunch of things that will never end up existing or won't exist for a long time, and you have to deal with the overhead of that. But thinking about what might happen can lead you to, I mean, essentially like to climbing the right mountain. Like you maybe don't have the perfect solution, but like you're at least, you know, on the right trail. You may not be to the finish line, but you're at least going in the right direction. You're not, you know, climbing up the wrong mountain. So, but the first thing I want to do here is all of these in their constructor, they have this code here. If party equals friendly, if party equals enemy. So depending on which party we add it to this parties dot add enemy party, you know, we like add it in, and every single one of these works that way. True programmer skeleton and the encoded one. And if we added another monster type like an Amarok or an Orc or a, you know, whatever, there's a lot of things that we could add. We would have to copy and paste this. So I want to limit our the overhead needed when we want to add in another monster type or another character type. So what I'm going to do is I have this character thing defined here, right? And what I'm going to do is I'm going to make an abstract base class, a public abstract class character. So this, like, I've got now, and this is going to implement the I character interface. So I still have with the interface, like this is a common thing where I'll make an abstract base class and an interface. The interface is like the bare minimum. This is what's absolutely needed. If I have a character that just doesn't fit the typical mold, I can always go back and just implement the interface from scratch. But with an abstract class, I can put a lot of the common things directly in there. And for example, I'm going to put these in here, and then I'm going, like, this also needs, well, this also needs these player action and AI action, and I'm going to just, for now, I'm going to just declare these as abstract methods and say, look, derived classes are going to need to override this. So these are not abstract. These are like, they should be able to just do their job. Derived classes are going to have to provide this, and we'll get to that in a minute. Um, but now, um, so now what I can do is I can come in here and say true programmer derives from character, not I character. I mean, it does indirectly. It derives from I character indirectly. But now I don't need to like redeclare these because it picks it up for free from here. Um, So like, and that's what it's going to say here. The keyword new is required on HP because it hides property that. So, and this is always been one of my complaints about these things. This warning, CS0108, true programmer.hp hides inherited member character.hp. Use the new keyword if hiding was intended. It hints at use new. Well, that wasn't the intent. I didn't intend to hide it. Uh, so in this case, new, I don't want to put, even though it's kind of hinting at suggesting new, I don't want new. I just want, like, now that it exists here, I don't need to declare it here. The base class has already given me those properties. They exist. So I can just delete those. Um, and then what I want to do here, so you can see like name and max HP, because I made those get only, I can't actually set them from this constructor. But so there's an easy solution to that, and that is I'm just going to come in here, public character, and I'm going to do string name int HP. Basically, I'm going to take that constructor that we had and put it here, and this actually can be protected. And now in here, name equals name, HP equals max HP equals HP. So I'm just, that's a, like I'm assigning HP into this, and then that, all of that into, so the HP gets put into both of those. And then actually I'm gonna copy this code for the moment and put it here. And all right. And now what I can do, so essentially now that true programmer derives from character, I'm going to need to call a base class constructor. And that's just, I'm just going to call name HP party. So I just take all the things I had and just pass it along. And then this constructor that we just made right here now does everything that's in here. So at this point, this can just be deleted. And a lot of times when I have it like this, I'll just put it all on one line like that. And now that's taken care of. Now, so now we just, because this is derived from character, basically we've shifted all that code. Essentially everything that was there is now just moved over into the base class, the character base class. This is going to need to be override. So you don't use the override keyword if you're implementing an interface, but since I am using these abstract methods here from that abstract base class, I do need to do that. And that's also going to be true here. So override. And now my character, this character should, like, this should still work exactly as it did, only now it just uses that character base class. And now I can do basically the exact same thing here. So I don't need these properties. This can just call base name HP party, and then curly braces, and then just delete all this, and then add override to these. And same with this one. By the way, we're now down to 525 lines, so we've lost 325, 328 lines of code total, which again, that's not, don't want to overemphasize that, but I am excited about how much of this duplicate code we've been able to clean up. Another thing that I'll say though is, uh, so again, like it'd be nice if this stuff here about like deciding which party to put it in, like I guess the concern, like this works, but what happens if I have like there's like three enemy parties. So it's this series of battles. I fight one group and then I fight the next group and then I fight the next group. What happens if I want 4 or 5 or 10 of these? Like how long, like do I really want to have like these um static like parties and have these methods here for like adding a character to a particular party? And I think if we could just like rearrange where we insert those. I mean, I think the only place that we are, yeah, there's only one place that we're using all these methods. And like I think, for example, if we came up here and instead of passing this in, like instead of passing that party in and expecting the object to get itself inserted into one of several static classes, one possibility here is we could say, let's not do that, and then do something like parties dot friendly party dot characters dot add programmer. Like this is an alternative approach, um, and actually, if we're doing that, I think we can just, I don't necessarily need the variable here. And in theory, we could do, the same kind of thing. We could do parties dot enemy party dot characters dot add new skeleton 1 5, something like that. And then so like we get, let's see, in the first one there's just the one, and then in the second battle we have skeleton 2 and 3, and then in the third one we have this, and then I can delete that. And then the only problem I've got is that I want to remove the party here and here, which also means coming over here, removing this party, and then not doing this, because this decision is now just made up there. So we don't need to, every time there's a character, I don't need to like go figure out which party to add it to. This just creates a character that is separated from any party. We insert it into the party afterward. And so we'll just do that exact same thing with the skeleton and the encoded one as well. And there we go. So now that constructor is much simpler. So now if I want to make a new character type, I can derive from character. I get a lot of stuff for free. Like I don't have to like add these myself. I can just like, I need a constructor that can give it the name and the HP. And for what it's worth, like the way we've got this set up, like this, like these have names like skeleton 1, skeleton 2, skeleton 3. Do I care about that? Do I want, and then you pass in 5, like there is an argument here that what I could do is I could delete that and say, I'm just always going to pass to the base class 54, and just always use the same name, which is going to be skeleton. Like I could do that. And then when you're creating a skeleton, you just say new skeleton. You don't have to think about what should I name this guy and how many HP should he have. The downside to that is I no longer have the ability to like customize the character's names or the number of HP they have. This is an approach that only works if every skeleton has the same number of HP and the same name, which may not be true. So I'm going to actually leave that as it was. But that is a variation on this. So at this point, yeah, now all of these methods are not being used. So now I can just delete them. And now this parties class is just a collection of the known parties. And what's interesting about this is, like, I could, like, people are hardly using these now. That's not true. I shouldn't say that. These actually do get quite a bit of use still. Um, I guess and I don't think I'm going to get this far. This video is already nearly 2 hours long, and there's something else I want to deal with rather than this. But I could imagine a future where this class doesn't exist. We just have a list of, we have a party that's the good guys, and then we have a list of parties that are the bad guys, and we just make those up in the constructor, rather than having this thing that creates this like static access to any party anywhere, anytime, for whatever reason. That it was just, we don't have to do it this way. Like this approach, I think it's fine. It works. But for example, if we want to load parties from a file or from a database, or load them from the network, or randomly generate them, or whatever it is, like the fact that we've got this like hard-coded list of parties, like kind of gets in the way of that. All right, where are we at? 485 lines. All right. So yeah, the last thing that I feel like I want to address is the fact that just the way that these actions are done. Let's look at how they, so each of these, true programmer has a player action and an AI action. Skeleton has a player action and an AI action. The encoded one has a player action and an AI action. I want to compare both how the two differ from each other, and also how like player action here differs from player action over here versus player action over here. So I brought up the player action and the AI action here, and like if you look at this, the majority of the code, there's an extra blank line here that isn't over here, but the majority of the code is identical. The only real difference here is really this right here. It's in the AI one, we just randomly pick a number between 1 and 3, and in the player action, we use the console to pick an action, which means that this is actually primed to like do something a little different, to like reduce all this code. So if I come in here and I say, all right, player action, so what I'm gonna do is private void run action int. Oh, actually, you know what? So this has this actions right here, right? So I'm going to say actions action. I don't know why I'm writing this out manually, but what I'm going to do is, so all of that, and then it's basically all of this right here. I'm going to just cut that, put it in here. And then right here, I'm going to call run action. And then the same thing down here in this AI action, this has, it's the same thing, like all of this we said is identical. So I'm just going to say run action. So now these two, like we just got rid of a fairly large chunk of code and just moved it into a shared method that they both call. The catch is that this is not working because this damage thing. And so let's figure out what that's doing, because we see damage equals 1, damage minus equals 1 it's like we see all this like the damage. I don't think that's like, it's just a local variable. I think what we can do here in both cases is, because this is now saying it's unused, so I think we can just basically take that and this guy and move it into here, and I think that's I think that's all we need to do there. So this is just a private run action method. So given the choice, we just run some particular action. And now this player action, like this is the logic for having the human pick. This is the logic for having the AI pick. And the shared stuff just happens in this little private method. And that I think is a huge step forward in terms of removing duplication. Because, for example, I think now we're down to 424. We've removed half the program now. And I think that we can do so. The skeleton is, I suspect, the same thing. Like I think that this is. I'll throw these into Beyond Compare as well, and we'll see. Yeah, so it's the exact same thing. In both cases, we do this like make a choice and then do some stuff down here. This also had like it's computing. I do want this stuff up in here, but I think this damage and maybe the random. I think both of these I'll just move down into that method. So I'm just going to copy the pattern there. I'm not like that code. I'm not right now, at least I'm not reusing the code from the True Programmer class. I'm just going to, but I am going to copy the pattern. Like whatever we did here, this like private void run action, I'm going to do the same thing down here. So there's no like actual overlap. There's no actual overlap, but there is like philosophical overlap. Like we're doing the same concept, and that is in the programming world is called a pattern or a design pattern. Is whenever you have something that you want to reuse, but can't just like reuse the code. It's called a pattern, and there's a lot of these patterns that exist that are like here's an approach, like a style that we've seen works well in a lot of scenarios, and a lot of times these patterns have like named elements, like there, for example, picking something random. There's the decorator pattern, and so there's like there's a thing that's called the decorator. There's this like all these things are like they have specific names, and if you can use these common patterns, then I can tell another programmer, hey, what if we use the decorator pattern here? And they're like, oh yeah, I know the decorator pattern, and what if we did use it? Maybe it looked like this. And so like it's a way to like communicate a lot with a few words. But anyway, so this is not like one of those like famous patterns. I'm inventing this, but I do think that we're not reusing code. Like this isn't the same method as that run. It coincidentally has the same name, but there's no actual relationship with that other run action method. But it is the same pattern, which patterns are great because again, like if I know about the decorator pattern and I see something that's called a decorator in my code, I'll look at it and say, okay, I'm expecting the decorator pattern and I know what to expect. So same thing here. Once I figured out how the true programmer works, when I look in skeleton, I already know how it works. So it reduces the mental load. And that is very useful. All right. So all we need to do is all of this stuff, put this in here, not, was a typo, and then right here just say action, and then I'm gonna do this off screen, but we just need to do the exact same thing to the encoded one as well. So now we've got that. Like all three of these, there's this like private run action method that runs the action, and then the player action just does the console input, calls run action, and then the AI action does the same thing, just randomly picks and then run action. So, and again, now we're down below 400 lines of code. We started at 853, so we've removed more than half of the code, but I feel like there's still a lot of like logic in here that is duplicated, and that is, for example, there's like all of this stuff here. Like, so when the player does it, it's like, here's your options, pick one, and then we like figure out which thing, and then we say, okay, go run it. And the AI one is like, it's different, but like as far as like the skeleton, the true programmer, the uncoded one, like all of those feel like they um, they are like the human part, the player part, and the AI part are doing essentially the same thing. It's just a different list of actions that it's got, right? Um, each of them have this run method, but then like the meat of it in here varies. So I do like there. I still feels like there's a lot of duplication in here that we could maybe still keep going after. But like I said, we're almost 2 hours into this, which is way more than I think anybody's really probably gonna like watch front to back. But watch it in double speed. You probably don't need to see all the little details. Anyway, yeah, so I do feel like there's still plenty of duplication here that I think we could do something about. But we've also made a ton of progress, and maybe that's good enough for now too. Hmm. I think like I'm trying to think of where to go next. And again, you're not seeing this on the recording because I'm not if I'm just sitting here thinking, I'm not like recording that. But one of the things that I'm itching to change is like this has like this enumeration of actions and it has nothing, which every character has, or punch. Or like in this case it's punch. But down here it's nothing and bone crunch, and down here it's nothing and unraveling attack. And for example, um, like what if like there's no reason why um well, first of all, there's no reason why you couldn't have multiple attacks. Um, for example, in this game, like the Vin Fletcher has, he can use the bow and do stuff, or he can punch or do nothing. Like there's like depending on what you're doing, like there's potentially multiple things here. Um, and is it, but the fact that there's like each of them have their own little secret private, and I mean technically these are private. Like the fact they don't have a access modifier on here, but they're nested. These are private enumerations that only this class can use, which works here. But I kind of wonder, what if we promoted the enumeration to a full-blown class? Like what if, because like the big like the duplication that's left here is um like I like all of this stuff I'd like to like unify, like this player action and one that's here in skeleton in its player action. Like the only difference is the tech, like the options. And like I need to be able to express this text as an action. And so like if I came in here and I said, well, you know what if we say public, and I could make a class, I think I make a record, public record action. And I'm gonna just keep this simple. I'm just gonna keep that simple. That's like it's just a name. And then um instead of this, like I'm gonna make like a public static class actions, and I'm gonna have a public action, public static action, nothing equals new action, public static action, unraveling, okay, it's new action, unraveling attack. So so I mean essentially this enumeration, I mean first of all I made it top level, and then second I turned it into like this is very philosophically close to just an enumeration. It's also very much not an enumeration just because like this is represented with behind the scenes just like an int value. In this case, it becomes it's a full blown object, and it has like a string here, right? Um, but if I delete that, then one thing I can do now is I'm going to say, so if an action, oh, it's kind of interesting how that worked out. So by making this an action, one of these, I pass that in and it says if action is not actions dot nothing. So if it's not this one, then do all this code. But what I think I want to do is flip that around and say if it equals actions dot unraveling attack, do all of this. So now if it's the unraveling attack, then we'll do this. And what I can do now is essentially do the same thing for the skeleton and turn this into an action singular, and I'll do the same thing here. So if it equals actions dot action dot bone crunch, which now I need to add. So essentially I'm going to combine these. Like this had this enumeration, and I'm going to add in bone crunch. So I guess in a way I'm kind of separating the actions from the characters a little bit, for better or worse. I got to do the same thing down here. And then I need to do the same thing in here as well. So I'll just delete this. And now I have to add in punch to that list as well. So one thing I will say is it kind of, yeah, this in here, all of this there's some stuff going. So if action equals actions dot punch, which that doesn't exist yet, but I'll make it. And the only reason I'm flipping this around is to me, it's easier to say, well, because either way, it's the same thing. In this case, it's if I've chosen punch, not nothing, then do this. Otherwise, this is the code for doing nothing. And but to me, this reads better because I'm not saying what it didn't do to get in here. I'm saying like in this case, like it's easier for me to mentally associate all this code is the punch code. There, everything looks like it's compiling again. That's just a baby step. And like I say, you could argue that this is more complicated. One thing I do like about this is that now there's like it's not an enumeration anymore, but it's kind of like an enumeration, one collection of all the actions. But one big difference here is we actually do, unlike an enumeration, I do now have the ability to just make a new action elsewhere. I could write code to prevent that. If I wanted to guarantee there's only a specific small limited set of options, there's plenty of ways to do that, and I won't get into it. But in this case, like I like the flexibility that we have now. One thing though that I want to say is, well, it would be, now that I have the code here associated with the attack, like this is the code for doing unraveling. And right now, the only way unraveling works is if you're the uncoded one. It would be kind of nice to I mean, maybe not unraveling, but it'd be kind of nice to just, give punch to a lot of different characters without having to copy and paste. Things like that. But I guess I'm still right now trying to go after the duplication that we have with these. If so, and I think I can do that. However, I can't do that right now. I'll have to do that later. So I think that's the plan, even though it's already a 2-hour video. Maybe I'll chop this up into multiple pieces though. I don't know. Don't usually take the time to do that. All right. We'll see what happens. All right. I've stepped away from this a couple of different times and come back to it. I want to try and finish this up. Hopefully this transition a few seconds ago isn't too disruptive because I don't really remember what I was doing this morning when I was working on this. Other than what I do know is that we're working on trying to simplify the duplication with these actions. I think one of the big things now, so we removed those enumerations that were hanging out in here, but the nice thing about that was that it was a list of here is the actions that this character can handle, and we do need some way to represent that, right? So we could do, for example, like I said, this list of actions where we have a specific set of predefined actions. Like I said, this is like an advanced enumeration that has more flexibility. I mean, maybe we'll get there, but for example, this is we can add more than just the name, right? We could add anything else we want to it, and we might get to that later. But what I want to do is if we just come in here and we say, so private list of actions equals new, it'll infer the type, and then we just say actions dot nothing and actions dot, what is this one? This is the uncoded one, so unraveling. So this allows us to, in here, to say, here's the list of actions that the uncoded one supports, and we can do the same thing for the skeleton and for the player character, the true programmer. But what I want to, let's just work through the uncoded one here really quick, because if we come over here to, so this is the player action. At this point now, what we can do is we can say, we can do this. We can say, basically, the difference between these two is whether we do display this and ask them to type stuff in or not. And I think we can just, so we can make it so that these are just use this stuff right here, this underscore actions. Oh, I can also make that read only, right? Because it doesn't change. So anyway, yeah. Oops. I meant to put an empty line after that. All right, so if I come down here, I'm going to do this AI one first because I think that's just a little bit easier. First, I'm going to move this random down, partly because this stuff I actually maybe want to put elsewhere in a moment. But now what we can do is so in this case, it's just a matter of pick a random action. And this random.next is minimum and maximum, but it, so basically this will give us between 1 and, it'll either be 1 or it'll be 2. It won't be 3. It'll be up to, but not including the max. So if we do the only so first of all, one thing I want to do is this is 1 to 3 to keep this in sync with this, right? I can do 0 to 2 and then change this to, so if we picked 0, we do that. If it's 1, we do that. But then at this point now we can actually just say that, like we don't need to specify a minimum value of 0. And then but then what we can actually do here is we can say, instead of 2, we can just say, well, because like what we want is just do it based on however many actions we have. All right, so we can just say actions dot. So we just figure out how many actions there are. That's all we really care about. And then instead of the switch, what we can do is we can say run action and then do actions at index, whatever was chosen. If that makes sense. So now, regardless of how many actions we have, this will just pick one of them at random with an equal chance of each of them. And that means that if we said, we want this thing to be able to do actions dot bone crunch, right? Now it supports that, and literally all I had to do in this case is come in here and just add it to the list. And that is that's really, really convenient. As long as it's an existing action, I can just put it in there. Of course, there's also this code here that describes what to do if we do run a particular, what we do if there is a particular action. So this right here is the code to do if it's unraveling. So if we wanted to include, say, bone crunch, we'd have to have another else if it's bone crunch. Here's the code for bone crunch. But yeah, so now we've got this. This is complaining about the capitalization of that. I'm going to rename that to, well, actually that right there, IHIs. Do a little bit of cleanup here. All right. And then, so this one here is essentially going to be about the same thing. Like we just say, name, choose your next move. The thing that's going on right here is, oh, that's interesting. I don't know if that's a mistake. I mean, it's got to be a mistake. I think this int.parse console.readline should, yeah, this has got to come after the menu, right? A bug, but it's not the end of the world, right? Anyway, this, now we present them the menu and then we just say pick something. So this is essentially the same thing. It's just that what we'll do is we'll turn this from a hard-coded list. We'll just do for int index equals 0, index is less than actions dot count index plus plus, and then we'll do console.writeLine, and then we'll put in here index plus 1, because that's the index is going to be 0, 1, 2, 3. It's 0 based, but the numbers we want to tell the user about we want to be 1 based. So we'll add 1 to get to 1 based, the little closing parenthesis, and then we'll do actions at that index dot name, and I think that's it. So and then I'm also going to delete. Plenty of people feel otherwise. I don't usually put the curly braces if there isn't a compelling need for it. If there's not something going on, I'm not gonna put the curly braces in. Though I will say, if I have an if, something, and then the if has curly braces because it's one line, another line, it feels weird to me to have an if with the curly braces and then to just put the else to indent it like that. Usually if one of them has it, I'll make both of them have it. So there are times where I'll use it even if it's not strictly necessary, but in this case, I'm not. I'll just leave it at the curly braces out. So now that should give us the exact same thing as this. And then we just get the number, which they will be typing in, theoretically, 1 or 2, because we're telling them, 1 or 2. So then what I'm going to do is I'm going to parse that, and then I'm going to subtract 1 from it so that we're now back to the 0 and 1. And then we're going to say, action equals actions at player choice, at the index that they chose. Although at this point, I probably don't need to store it in a variable. I can probably just do that. Embed that right there. So that's the player action, and that's the AI action. And now, like if we did, so for example, if we said, you know what, we don't want the encoded one to have this unraveling attack, we would just delete that, and now it's gone. And this code doesn't have to change to reflect that, and that I think is a really good thing. Obviously, we still want that unraveling attack, so we're going to keep it. But now let's make. This feels like it's inserted. Actually, both of that too. Let's move this out of this spot. I don't want to split up the characters. So I'm going to move those up to here. But again, like I was talking about earlier, like this idea of patterns, we want patterns to, like, we'll reuse the pattern even if we can't reuse the code, although I think we're going to try to reuse the code here in a little bit too. But what I want to do is the same idea. I'm going to just take this and stick it here in the true programmer. And other than, so this is nothing and punch. And then, so I'm going to not worry about this run action, but like this stuff right here, honestly, and this is the best part of this, the code that I just wrote is exactly the right code. Even so, like in this case, like we should be using nothing or punch instead of nothing or the unraveling attack. But if we use the same code that now, because that underscore actions has nothing and punch, we get this, like the same code. All of this will work the same over there for its set of attacks. So I'm just going to take this and just replace all of this. And you might be saying, yeah, but what about that duplicate code thing? Like now you just copied and pasted code, and I absolutely did. So we'll worry about that in just a second. The same thing applies here. And then let me grab this other line. Drop that in there, and this guy gets attack actions dot bone crunch, right? So there, they all have that code now. So that, yeah, it is copy pasted. Now all of our character types they support this idea that they support this idea of, like, you know, it doesn't matter what things I have. Like I can add and remove actions from this list here, and the uncoded one works, the skeleton works, the true programmer, they all work the same. But we can deal with that whole the duplicate code, because now at this point, this and this are 100% identical. And so what we can do, remember, this now derives from this character base class. We could just move that code to the base class. And so I'm going to just do that. So if I just delete those, come up here to these and just place them here. And now those were this. I don't need those to be override anymore. I just let them do their thing. And now I have some patching to do. Actually, let me back up here. I think there's another way that, like, that this is really where it's going to end up at, but I do want to just back up just a second here, because I think that we can make a smaller step. And that the first thing that we can do is we can say, let's move. Actually, let's move these up above the character class as well. Actually, probably above iCharacter. Let's put them way up here. All right. One thing we could do here is we could say, we could make a, basically, let's move this list of actions. I'll copy it for the moment. Move this to here. And at this point, I don't need, like, I don't know what actions a generic abstract character is going to need. So I'll just make the list here. And then if I make this protected, then in the true programmer class right here, I can say actions.add actions.nothing and actions.add. So I put them in there. Now the actions are defined up here in this protected thing. I actually debated, and I feel strongly either way, but like potentially you could make like have the actions passed in as a constructor parameter instead of having like to do this in the constructor. That's a legitimate way to approach that too. But because this is now like the true programmer doesn't have that its own list anymore, it lives down in the base class, so it inherits this. It is still there, but this doesn't need its own dedicated list. And yet everything here still works, including like this part right here, because it's just pulling it from what it inherited from the base class. And the same thing, we can do the exact same thing here. We can do actions.add, actions.nothing, and actions.bone crunch. Get rid of my, and you'll like, this is going to say, yeah, the keyword new is required because there's already one in the base class. Well, we just don't need both of them. We can get away with just the one. Just delete that. We're good. And same with the uncoded one that we can just in the constructor here say actions equals actions.add, actions.nothing, actions.unraveling. Delete that. And now we pushed that underscore actions list to the shared class. Now at this point, it should be really easy to take this like duplicate code here and just move this to the base class. So we're going to replace these abstract methods with basically what is at least right now their one and only implementation. So we don't need to make them like virtual or anything. We just do that. And we do need to do something about this run action, but I'll come back to that in a second. At this point, I can delete this because now player action and AI action will do this exact same thing. It's just what's defined in the character class. And so I can also delete this. And okay, that's all of them. So the one thing I do need to do is there's this like the base class needs to use this run action. Each of those right now have their own like version of that. So what I can do is I can introduce a protected abstract void run action. So I can say, look, I don't know, like at the character class level. So before we had player action and AI action as abstract methods. And now we're saying, look, I know how to do that. It's just this little piece of like, how do I actually run the action? That's the only part that the character class doesn't know how to do. I need to like defer to the characters themselves to sort this out. So I'll leave this as a placeholder. It's a little piece of the overall like action. And that's good enough to like get the action working. So now like every derived class is required to implement run action, but the base class doesn't know about that. So here now I just put in override these were private before, but in order for it to be part of this like inheritance hierarchy, these have to be protected. So make that one protected, come down here, make this one protected, and override. And same here. Protected, override, run action. Okay. I'm missing something. Oh, nope. I just had to wait. I just saw the red line in there and was wondering what was going on. I just had to think. All right, so now with that, like we've gotten rid of, again, a lot more duplication. We're down to 333 lines. So we've lost 520 lines out of 850. So the only, like, I actually don't think there's a whole lot of duplication left in this program. So I don't think we're going to get much shorter. Well, if there's duplication left, it's maybe all in like this stuff here. It's like if it's punched, this is what you do. If it's punched, do this. If it's, so depending on the, which enemy party, we just do punch. So related to this, there is that duplication here that depending on this, like this code here is almost identical to this code here, except that we use, like this uses the second group of enemies. And again, like the way this is set up, it like punch can only be given to a hero. We couldn't give, we couldn't give a skeleton punch. We couldn't give the uncoded one punch, and vice versa. The code that we have here for skeleton, for bone crunch, assumes right here that we're targeting the friendly party. And that is actually like, that's going to hold up. Like through this entire challenge, it's going to hold up. Like that we never end up in a situation where a skeleton is on the, the hero's side, or where one of the monsters is doing punch. It doesn't, like, strictly speaking, it doesn't have to be that way. And it'd be nice to like break that up, partly because I think that like this stuff here is all basically duplicated. It just depends on which enemy party still has characters that are alive, right? So like here, it just says like if there's something still in that first party. So it also means that, like, for example, you couldn't like, trying to think of a good way to describe. So you couldn't like warp past the first enemy party, leave, like, just like, some character couldn't have like a magic spell that just like skips, like jumps past a existing set of monsters or anything like that. Like, yeah. So it would probably be ideal to like not to like. Sorry, I'm distracted because I got a cat. It's the same cat as yesterday. Got a lot of opinions about what I should be doing right now, and they all involve him and food. So, like, one thing we could do about this duplication is we could, because like the only real difference here is which party we're using. So like we could do something like call a method, like we could move this code into a method and pass in the party to look at. So for example, we could do, like, I mean, there's this damage here that I think if we do make a method, so what I'm gonna do is I'm going to extract a method, and I'm gonna call this like run perform punch. The problem here is what I need. I'm missing a parameter, and that is, do I actually need this action? Yes, I do. Perform punch, and then pass in the party. So we pass in the party, and then I think we can just declare this here. I think I like that better. And then here we'll just use, like, I selected that, and you can see all the places that got highlighted. Like, this code is very dependent on like knowing which party specifically. So by replacing all of our usages of enemy party here with this target party, it makes it a lot easier for us to reuse this code with a different party. So now up here, we've replaced a lot of that stuff with, so this is perform punch with, we pass the action, then we do parties.enemy party. So the functionality is identical, but here's, I was saying this earlier, like, given that the if has the curly braces, I'd like, well, I was gonna say, it's good for the else to have it too. Like, mentally, I like that balance, but the if doesn't need it. There. So if there are characters left in the first enemy party, then we are going to perform punch on the enemy party. Otherwise, we're going to do, basically, this is the do nothing. Name did nothing. Down here, it's the same thing, but now we can replace all of this stuff with just perform punch with action, and then parties.enemy party 2. I like that white space a little better, maybe. And then this one here is the same thing. We just use enemy party 3. Don't need this damage variable anymore. There. I like where that's going. I don't think we're done yet. But now, like, that is, honestly, that is really about the last duplication that's in here. So we're now down to 300 lines of code instead of 850. So we've gotten rid of 550 lines of code. And I think we've gotten rid of all the duplication. There is still a couple of things that I'd like to do. And I think I'm going to do it. Like, so for example, one of these is like all these else's do the same thing. And so this is like, it checks the parties one at a time. And what if we flip the order? So we see what action we're doing. And then if it's punch, we'll like work our way through that. I feel like that is a little bit cleaner. So if we just say, if action equals actions dot punch, else we'll do this, and then so now in here we'll say if parties.enemy party dot characters dot count is greater than 0, perform punch action parties.enemy party. These need to be else if. I'm tweaking the white space there to like make it line up better. Although there's one thing that I thought about doing for a long time, and that is the symmetry here. This is just enemy party. This is 2, 3. Like, why not just make this enemy party 1? So now we have like symmetry. And I like one of the things I like whenever you do have that symmetry, it makes it easier mentally to like understand what's going on. Cause like I can see like this is just a pile of if statements and their conditions are all very similar. There's just one difference here. And what is it? Well, it's like this character, this column right here is what's different. It's 1, 2, and 3. And then of course over here, 1, 2, and 3. So that can replace all of this here. And so I like where that's at, but I do feel like if we I think that this structure is something we could just about achieve. Like we could get a very similar structure in the skeleton and in the uncoded one. And so like I guess one thing I'll do is I'll say, like I know where I want to go with this. So I'm kind of thinking out loud here. Like I maybe haven't explained myself very well, but I do like one thing I feel like is what would be nice is if the action itself, like what would be nice is if we could just say, if in here to be able to just say to basically move this code to the action itself. And then have like derived classes for the different action types. And then we'd be able to in here just say like action dot run and pass in whatever we need. So I guess I'm kind of like, that's the direction I'm going is like, what if we move the logic for the punch action to like that class that we made? Because I think that gives us a lot more wiggle room for like adding in new action types and things like that. So there's a part of me that wants to say, well, let's just go ahead and do private void perform nothing. So this is an action that's do nothing. Which is kind of weird, right? To have like perform nothing. But I'm going to it's because there's similarities between these, and doing that it paves the way for interesting stuff ahead. And actually, so this has like target party with nothing there isn't necessarily a party, but again, for that symmetry between the different action types, like I know where I'm going with that, and it's that eventually these will be part of the action class, and I need them to all mostly look the same. So one thing I could do here now is I could just say, basically, I keep rearranging this right, but if I do if parties dot enemy party 1 dot characters dot count is greater than, let me do it this way. We're going to say party target party if And then right here we can say if action equals actions dot punch, perform punch, action target party. Else if, again, just kind of introducing this like symmetry, and like this is, I'm gonna change this all soon enough. I guess like that's saying it may not be initialized, which is true, which means that maybe I could just do else, something like that. Maybe that applies here too. Else. All right. I mean, that does the same thing. There's some things about what I just did that I don't love, but I do like that. Like I pick the party, and then depending on the action, I just like run it. What I'm gonna do, and I'm gonna pause the recording and just do this off screen, but I'm gonna do I'm gonna create the same kind of method for Bone Crunch and for the unraveling attack, and make those other the skeleton and the uncoded one structurally look like these, and then we'll go from there. All right, let me kind of recap where I'm at. So, the true programmer, like I said, we go through here, and because this is the true programmer, we know the enemy is going to be one of these parties. So we just like work our way through to find the party that doesn't, the next available party that doesn't have, that still has something alive. I think there are issues with that approach in the sense that like I don't know that that's like it isn't about like, well, what is the current party, what, like we don't know the actual context. We're just making an assumption that it's whatever one is the next available one. We're also making an assumption that the true programmer never becomes a traitor, switches sides, right? Which, like I said, for the what's happening in this challenge, like that isn't gonna happen, so it's not a problem specifically. But anyway, it does have its issues. Again, I would like to change it, but I also don't like. This video is super, super long already. I don't want to overdo it. I have already probably overdone it. But anyway, there's stuff you could do about that. It's maybe good enough for now. But yeah, so we have like, depending on what it is, we'll either perform punch or we'll perform nothing. And then the skeleton is about the same. I copied this perform nothing over, but like the alternative is if it's a punch, then it's that. But in this case, because this is a monster and it always shows up in one of the monster parties, we just implicitly know that like it's going to be the friendly party is like the target. Again, like that means there's no chance of having a skeleton that's a traitor and joins the good guys, right? That's not like in the grand scheme of things, you couldn't always make that promise, but this is a good enough start for now. Like I said, I think that you could, like, for running an action, you could give it the context of like, well, what team is this guy on and what is the enemy, like give it like the entire battle and then let it decide what to do. And that would allow us to just like not, it would allow us to like use what's given to us rather than like invent it from nothing. But it's fine. One thing I'll say is I noticed when I was going through this and like swapping these with target party, there was a bug that this was like removing from the friendlies. Like it was removing the dead monster from the good guy side. So I don't know that there was ever actually like cleaning. Like I don't know that it actually got rid of. Oh, maybe you know what? Now that I'm thinking of it, I might have that backwards. Let's see. No, I mean this is we like if the character dies, it'll be if the character dies, it has to have been from that target party. I mean, at least the way it's done right now. Like again, you could have something where like somebody deals 1 damage to everybody in the entire game, and maybe you kill one of your teammates or yourself for that matter. Um, but yeah, no. So I think there was a bug here before that got sorted out by like switching it to this target party, and the uncoded one looks the same, and so anyway, I like where this is at. And what's interesting now is like now we've created some duplicate code. Um, in particular, like all these perform nothings are all like all of them have that. So because everything has the ability to do a nothing action, that's all in there. Um, but like I said, the last thing that I think I want to do before walking away from this, moving on to to being done with the video because this is already a really long video, is if I just want to move the code for these actions to the actions themselves. So what I'm going to do here is I just made this action record, and it just has a name. What I'm going to do is I'm going to make this a class, and I'm going to public abstract class make my constructor, and then what I'm going to do is I'm going to do public abstract void perform action, and I'm going to pass in the target party. So that's an abstract method. I don't need to like do anything with that. But then what I'm going to do is I'm going to public class do nothing is derived from action. And then of course I'm going to, public do nothing. This needs to pass to its base class. Oops, curly braces. And then, let's put my curly braces like that. I want them up there. And then we need to do public override void so we define this, and now this do nothing code. So what I'm doing is taking the code that was all these like perform nothing, and I'm just going to get rid of those and just move that into here. That's slightly problematic. This name used to refer to the character, it now refers to the action name. And so really what I think I need to do is maybe call it source. Whenever like that, again, this like symmetry, source and target I often use. And so now I want source.name did. And this name is the name of the attack. I maybe want it to be like that. So public. Oh, and then this needs to be yeah. There. Okay. So that's our do nothing action. It's pretty straightforward. And then now down in here, I'll say do nothing. Don't even need the parameter anymore. And then I just need to do the same thing with the other ones. And again, it's just coming down here and taking the code that I have for punch and just moving it into the punch action. So I'm going to, again, do that off screen. All right, so that's that. I got each of these now have this, like, they override their action. This one doesn't need to do much. Punch, I took the code from the perform punch and just moved it into here. I took the code from bone crunch and moved it into here. I took the code from unraveling, moved it into here. And like I said, again, now at this point, each of these action types, like, they don't really care. They don't really care, like, which team they're on, because, like, we just pass in this. They don't care what character it is. They just, all that gets passed in. And now, oh, I didn't quite finish this, but new unraveling. I do have to change these to do the correct specific types here. I mean, at this point, like, do I need this set of, like, predefined actions? I could probably just say new punch, new bone crunch in the places that are using these, and it'd be fine. But now the last thing I need to do here is, at this point, like, if actions is punch, then what we would do is say action dot perform action and pass in the character that is doing it, this, and then target party, right? Or down here we'll say action dot perform action, again, this, target party, except that's identical. It doesn't matter what it is now. All we're going to do is say that, take the chosen action and just run it. And so I'm just going to replace all of that with just run the stinking thing, right? Interestingly, that is also identical for the skeleton and the encoded one. And other than the fact that, like, so now all these things are the same, with the one exception of, like, deciding which party to choose. And I guess one thing, like, we could do, like I said, the way this is set up right now is any of the heroes, this is the logic that we use to, like, pick the target party. So, like, I could do, let's make this into a method. Pick target party. I actually don't want that static. And you know what? At this point, like, now that it's in that method, I kind of want to just say, instead of putting it in the variable, just say return the first one. Otherwise, return the second one. Otherwise, return that one. Oh, hey, and then I don't need these else's either, because as soon as I find one, I'm done, which means less indentation. Now I don't love this. Okay, anyway, that's fine. So we do that, pick target party, and then perform action. And then the same thing goes for this, other than just, well, so the way we did this, we had made, pick target party. I'm actually going to down here and put this here. It's just that in this case, I'm just going to say return parties dot friendly party instead of this. Except if I'm going to do that, I might as well use an expression body. Boop, same thing. And then I can do this. I hope you see where this is going. I am, like, now, like, this code is all the same, except that, how do we decide which target party? And now for the skeleton, for the uncoded one, this is identical. So, and now if you look at this, like, the run action for the true programmer and for the skeleton and the uncoded one are all the same. So what if I made it so that this wasn't the abstract thing from the base class? What if this was the abstract thing? So let me go back to, I'm going to copy this. So what I'm going to do is I'm going to go to the character class, and then instead of making this abstract, I'm going to make it not abstract. And then I'm going to make this protected abstract pick target party like that. And then, so now all of these, basically, we don't need to have the run action in here at all. We just need to protected override pick target party. That's true for the skeleton here as well. And then this one, like that. Now, the other thing I'll say, I keep finding all these little things like we could do this, we could do this. This is always a problem with refactoring is you have to at some point say, well, when am I going to stop making changes? And I'm actually, somebody just asked this in Discord, and I actually think it was the same person whose code this is, who's actually already spent, aside from me, spent some time doing some refactoring. When do you know when you're done? Well, that's hard because a lot of times I can keep finding little things that are worth changing. There's two parts of the software that, two bits of value that are provided. One of them is the, like, what does the software do? And obviously, like, that is an important part of the value of the software. If it doesn't do anything useful, it doesn't solve any problems, if it isn't entertaining, if it's a game, like whatever it is, it's not useful. The other side of that is the structure of the code, because there's this expectation that when people say, I don't want skeletons to work that way, I don't want this to work that way, that it's easy to change. There's this expectation that software is easy to change. And so the users don't see that aspect of it, but it is very real. And it's the softness of the software. It's its ability to be changed over time as we change our mind about stuff. Both of those matter. So at some point, like, everything we've been doing here is not like, we haven't delivered any more like user visible value in the software. Everything we've done has been like that, the softness side. And I think we've gone a really long way. Like, this accomplishes this. And I mean, there's been enough changes here. There's probably some bug that I accidentally introduced, but we went from 853 lines of code to 325. We removed 525 lines of code, and it does the same thing. So it's less code to maintain and accomplishes the same thing. So like the softness side, I think we've gotten a lot better. The like business value side, we haven't really changed anything. And so at some point you say to yourself, I need to stop tweaking the code because it's time to move on to the next big feature. So sometimes you kind of run out of interesting stuff to do, but more often you get to a point where you say, look, I've made enough changes. The next feature is easy to add now. Now that I made these changes, the next feature is easy to add. And so I'm going to just, move on. I'm going to stop refactoring, even though there's more that could be done. Like I said, I still think there's a lot more that could be done, but I do, like I said, this stuff, this code and this code is identical. And if we said we're going to make two character types, I'm going to make a public abstract class monster, which is a character. And we said this is going to live there. And then we make skeleton derived from monster. Oh, I do need that constructor. So public monster string name int HP. Just pass it along. Name HP. Like that. That could be protected. And so now this derives from monster. And then same with this. This derives from monster. And then I don't need this anymore. And if we also said, I'm kind of inventing terminology here, but abstract class. So our other category is hero. And we said, you know what, it's essentially the same thing, right? It's just we're going to use this code here. And then we make the true programmer derived from hero. So the difference between heroes versus monsters is heroes will only be in the friendly party, and monsters will only be in the other party. And like I said, that's a choice that we've made at this point. I don't like we don't that's going to be fine for everything in the final battle challenge. There's nothing that will drive us to do anything different. But one comment I would just say is it's somewhat arbitrary, and in the back of my mind I'm thinking, yeah, but like, why? I want to be able to, if an orc dies, I actually want to be able to have a spellcaster or like a necromancer, like bring the orc back to life as a skeleton, and now I have a skeleton in my party. Like, why couldn't that be a legitimate thing? So I actually don't like this like dichotomy of monsters and characters that decide their target this way. Like I said, there's also this assumption here that we will totally wipe out every party as we go. There's also an assumption here that I only have 3 parties. Even if I do end up saying I'm going to add a fourth and a fifth, like, this code has to change. I'd rather not have to do all that stuff. So there are, like, we're still boxed in a little bit. But let's just look at what we do have. At this point, if I said, you know what, I want another monster type. So like public class. If I said... I'm trying to think of a good public class. A beastling. We can get most of the value by just saying this is derived from monster. Like, that already ensures that like it's part of, like, it'll like chooses its attacks the right way and all that stuff. And then we just, it's like all these other ones, like you pass in the name and the HP. I don't mind that, but like I mentioned this earlier, why not just say, well, all beastlings have 6 HP and they're just all going to have the same name. Is that right? I don't know, but and now we just say actions.add. Well, these can do nothing, but they can also do new a new like growl action, and they can do a bite action, right? So, and then I can come here and I can say, okay, I'm going to add in public class growl is an action derived from the action class. And then all we have to do in here is, like, we have to pass in the name, and then we also have to, we can just give it the logic. So constructor doesn't need anything more than that. And then we can just say, well, console.write line rar, either rar. Like whatever the consequences of the consequences of a growl is, we just do that here. And if I said growl and bite, like, again, like whatever the whatever the thing is, like we can say for each character in target party C dot fear plus. Like if there's a fear, like roar, it increases the fear in all of the characters. Whatever it is that we need to do, it makes it really easy for, like, any new action type is just easy to add now. Any new character type is easy to add now. Actions. this isn't a thing, so I'm going to leave that out. So this actually still compiles. But now like I've defined like any new action type I want, any new monster type I just added in. And now I can just come in here and say enemy party 1, add new beastling. And like there. So now I don't have to specify 5 HP every time for a beastling, which was 6. All beastlings have 6. And in theory, I don't need any of those lines. In theory, now I'm hesitant to just run this because I've done so many edits without actually running it that who knows what this looks like. But like I said, in theory, now it's really easy to add new action type. It's really easy to add new monster types. It's not hard. Like if I want to, now that I define growl, if I want to say actions.add new growl, it's really easy to add an existing action type to a specific character. I mean, heck, I could come over here and say, why shouldn't the true programmer be able to growl right back? Like it makes it, this structure has made it really easy to add in all sorts of features, which is a really good goal to have. Like that's a really good place for us to be in. I just want to say I did run it, and I probably caused this issue. But like, so I said do player versus player, and then I entered it. Like I had my name in, and I said, what do I want to do? I want to punch. Arby did punch on true programmer. I damaged myself, and then the skeleton did that too. So I think I've somehow got the parties backwards. So that's a bug. I don't know that if the original, like I'm assuming I messed that up somehow in all my changes. That's kind of a comical bug to have. For what it's worth, and I don't know where this went wrong, but like this right here is the issue, is I've got hero and monster like backwards. So this is like, who am I attacking? Well, hero is attacking the friendly party. So if I put this code here and this code here, I will have fixed that. I probably made that mistake just right there in the last second when I made these two, but that should fix it. Otherwise, it actually looks like it's generally doing what it's supposed to do. Oh, I closed that window already, but player versus player, punch. And now it's the skeleton's turn. And so so now I have, like I said, I have this new character type, beastling, and I can do a growl, and I got the roar. Let's do another punch. And then we'll do bone crunch, and then I'll do my other attack. That was bite. And you can see like it's generating the menu on the fly, chomp. So anyway, I've spent way too much time on this. My cat says it's time for dinner. He's right. It's time to go to bed, in fact. So I'm going to stop here. I like just to kind of like recap a lot of the stuff we've done. Like this started, there's a lot of static things, and we've just like embraced objects a lot more. And that has given us a lot more flexibility. Now, obviously you can misuse objects, and a lot of people who complain about object-oriented programming have had some bad experiences with poor object-oriented structures. But again, like if you look at like how this is set up down here, for the types of things we're likely to do, new action types, new character types, like changing like the HP of a character, changing the actions that a thing supports, you know, that type of stuff is, we've made it so that adding those things are relatively easy. I think about the only thing that might be a little tough would be adding in additional like rounds. Like this right now has enemy party 1, 2, and 3, and to like make it so that it can have 4 or 5 or whatever would be a little tricky. Not that it's hard to like make a few more here. It's the places that these are used that I think it has the trickiness. And so I'm not too worried about this where we're adding them. The part that I'm most worried about, like if we did more, we'd have to change this. But I think this part right here is, this is really the part that I think is the trickiest, is like how is this going to decide that? And like I said, some of our choices have made it. If we ever got to a point where we said, you know what, there's no reason why the true programmer couldn't flip to the other side, or that something that is defined as a monster couldn't flip sides. There right now, each character type is very locked into like its alliance. It's like whether it's a monster or a hero, like that's decided by its object oriented type, and there's not a lot of getting around that as we've structured it. So that would be hard. I also think that if we said, well, we want to do like a network player, we haven't totally solved that. But hopefully you could imagine, like in this case, some of the stuff of like, how do I choose one of these? How do I choose an action? Like we could push that off into like a human player, an AI player class, and then we just make other classes. So again, a lot of problems can be solved by an appropriate application of object-oriented programming. But the other thing I want to say is like, again, I'll start with I'll repeat what I started with, and that is that this person put in a monstrous amount of effort. It shows, and it's this code. Like, yes, I've removed a lot of the duplicate code that the original author was also kind of like saying this doesn't feel right. So they are on the right track by like asking themselves all these questions, and B, it's their comment in the beginning was, I know it has problems, but I think this is a good first step. And I 100% agree with that. I think what we started with was a really good first step. I think we've evolved it in some interesting ways. I hope that this type of analysis and discussion makes it easier for not just the original author, but everybody to like start to see like how can I use objects to get the most of things. I do want to say like the person had made a comment. I think it was the same person who wrote this, but said something in Discord about like cleaning it up is one thing, but like I feel like if I just started over, I'd end up with so much better code because I've learned so much. And there are times, I'll say there are times where throwing the whole thing out and starting over is the right thing. It's really easy when you have a 20-line program. It's really easy to just say, you know what, this isn't right, and just throw it out and start over because you're only throwing out 20 lines of work. Where we're at now, where now I have 360 lines of code because I've added in some stuff. But even like we started with 850 lines of code. You're at a point where you probably don't want to just throw it out. And if you have a million lines of code, you don't just throw it out and start over. I mean, like I said, there are exceptions, but for the most part, you don't just take it and chuck it and just say, whatever, I'll just start over, because there's so much there. This idea of taking what's there and figuring out how to evolve it in little steps to turn it into something different, better structured for what you feel like the needs of the software now are as you learn stuff, is a useful skill. That refactoring, that being able to turn without changing the functionality, turning the structure of the code into something that is a better fit. And so I think that's that idea of refactoring as you're going, and continually working on the structure of the code, not just the features that are added, is a really important thing to do. Anyway, like I said, there are a few reasons I did this. One of them is because I think that the sort of like a lot of people start with a lot of use of static, and I think that I think that we still end up with a number of static things in here, but using like full-blown object-oriented stuff, when used appropriately, really does give us a lot more flexibility, and that's a win. But I will say that it's a lot easier to envision what objects should exist. I mean, you probably saw that like with these actions. Like I had a plan 6 steps ahead, and I just started evolving toward that. And these things are not like, for me, 20 years ago, I would not have seen the same things that I see today. It takes practice and experience and tinkering. To just see what works and what doesn't. And you have to be willing to like try out some stuff, be willing to fail, be willing to just say, well, that was really ugly. That was really dumb. I don't like that. Undo. I will say version control does wonders for that. If you can commit frequently, even if you don't like push it to GitHub or anywhere else, if you just use version control on your own computer, it's really nice to be able to make a little step and say, ooh, that's weird, and just revert the whole thing, and then to try something else and say, oh, I like that, commit it. And then you can just keep making these little baby steps. Goes a really long way. But yeah, I don't usually do this much like analysis or like changes to the final battle, just because I really like the final battle is people put in a ton of work, and I don't like none of the changes I've made here are meant to say like, oh, the other way is wrong or anything like that. This is just what felt like a decent approach to solving some of these issues to me. And if you didn't see these, like maybe like just because it's, if you didn't see the changes, like if it didn't come to you that, hey, maybe I could try it that way, don't worry about it. It takes time. You'll get there. But also, like I said, if you look at some of this stuff like that, I don't really like that. There is so much about programming that is very subjective, that like it just depends on the person. And it depends on a lot of little nuances. So yeah, I'll stop rambling, but I will say that the other reason is that I enjoy refactoring. For me, it's fun to like restructure the code. At work we have this thing that's called hackathon that's meant for people to like find little random projects and like try something out and experiment and hopefully build something that like is valuable to the company. We get 2 hours every sprint, every 2 weeks to do it. And I spent it refactoring some stuff that's been bothering me. So definitely something I like. Not everybody likes it, and that's okay too. But anyway, hopefully this has been useful. I've gone on way too long, so I'll stop. But thanks for joining me. You made it through 2.5 hours of video, however long it is. 3 hours and 11 minutes. My apologies that it went so long, but anyway, there it is. Thanks for joining me. I'll see you next time.